All right, here's a special Sunday edition of the program. New and guest in the studio today is Bo Groom. We are going to look at a logistic growth problem here. And the one I want to look at initially is this feller. Point O, well, dy dt equal 0.02 parentheses, oops, times y parentheses like 400 minus y or something. Okay? So what I've done is over here I've made myself a stock for the population. I put a flow into it. And then when I hear a variable out here called carrying capacity, then notice it's linked to the flow, which I call rate of growth. And population is also linked to the flow. So if you click on the flow, what I'm going to do is, again, click on this drop-down menu and then type in your function, 0.02. Oh, that's 0.2, stupid. Try again. 0.02 times the population times parentheses carrying capacity minus the population parentheses okie dokie, and then hit simulate. Oops, wait, I forgot to tell you. Stop, slow down. Now, in the population, I start off with 100 initially. Okay. And then the carrying capacity, I just put in that the carrying capacity was 400. Okay. Now, initially, the settings, okay, initially they are, and thank you to Bo Groom for pointing that out again. When I first simulated this, what the heck, Mr. Groom? It jumps up past 400. What's going on, brah? Alright, and by the way, your default display will also have carrying capacity on there at the same time, which is kind of cool but kind of annoying too. But anyway, look, we started at 100 and we shot up past there. So I was sitting there trying to figure out why that did that. Well, the biggest reason in my mind was is we need to change the settings. So what the computer does is it's actually using, well, the way it's doing it right now, it's using the Euler method, like we did in class the other day, to be able to go, okay, so suppose I start here, and we know what our rate is. So if we start at 100, we start at a population of 100, where you get 0.02 times 100 is 2, okay, and then 400 minus 300 is minus 100 is 300. So 2 times 300 is a slope of 600, for crying out loud. So even if you only go over a short distance, like say 1, well, then you're going to shoot up 600 units. Well, that's kind of ridiculous. So I knew that's kind of what the problem was, but then it finally pointed out to me that if you click on settings, we can change this from years to seconds or whatever. Like if we're doing it today, we're doing free fall, we want that in seconds. So, choose seconds, obviously. You can make the time go longer or shorter. And then, of course, this, because it's population, I want years. And later on, we'll actually change this. So we'll do the Runge-Kutta method later. But right now, Euler is sufficient for what we're doing. And currently, you see it's on 1. You can click on this, and it was also pointed out to me that you can just type in 0.1. Because, yeah, the man's a genius. Or you can click plus or minus until you get there. This should be sufficient. If I hit apply now simulate. Oh, that's pretty good. But notice by the time you get to time equals 0.4-ish, 0.5-ish, you're up to the top already. And so what we can do is change that up a little bit. And so I actually changed my function. Obviously you can't change that in the real world. Hey, sheep, breed slower. But, for the sake of this problem, I can. So I can put 0.02 in there. Slow it down this way. In the case of my graph, if I want my graph to look better, what I can do is have it not go as long, right? So I can have it only go out to, say, 5 years or something. And if I don't change my function, but I just change the window, it looks a little better, obviously. That's still not exactly what I wanted. But again, so suppose my population had actually changed, and they weren't growing that fast. In fact, they were only something like 0.02. 0.002, rather. And now I simulate, and voila, lo and behold, what? That's pretty, Mr. Groom. But I feel like we can go a little further because it'd be kind of neat to see all of that mess. And so, of course, just bump this up a little bit, just a skosh. And then voila, there's our simulation. Oh, this is so pretty. Booyah! Just exactly like we thought. Okay. All right, have a nice day, folks. Oh, wait, I know what you want to know. Some of you are thinking, what if this population was 700 initially? It's a great question, by the way. I think it was Jacob Hawkins that answered that question. Nice job. And, oh dear, I don't see it, Mr. Groom. Where did it go? Because it's way up here. It's coming down. Oh no, I don't think 10 is going to be long enough. So, let's go up here to our settings. Let's make it go out to, I don't know, 30 or something. That probably ought to do it. I bet. And I don't know if it's going to work now because I changed it. Well, it's probably not going to change. Let's try that again. Go faster, you hippie. Oh no, it's still not working right, Mr. Groom. I know. So scroll down to here. Let's make our y-axis. Again, this can be typed in. If I go up to 600, remember it started at 700, but I should see it kind of start to come down after a while, I think, maybe. Oh, I didn't hit play. Did I not reset? Maybe I didn't even reset. Alright, let's do two things here. Let's first of all, not there, stupid. Let's go simulate. Okay, now I'm just getting mad. I am just getting mad now. For crying out loud. What is wrong with you? Actually, I'm going to do this. I'm going to do two things. First, I'm going to do this. Make it go longer. That ought to be enough. What? Oh, it's fine. One thing we should pay attention to is, as was pointed out to me just now, this is why Mr. Groom needs help. So it's good that I have a guest in the studio with me today to record this. I bet it'll work now. What do you know about that? Let's pause and make this graph look better because that kind of looks like crap. Seriously, I think I'm going to have Bo come and hang out with me all the time because if I do that, it'll look prettier. Let's change my x-axis because right now it's ridiculous. It doesn't need to go out to 77. Oh no. Let's go out to like 20 or something. That's probably lots. Hey, there it comes. Okay, great. Anyway, so special guest, thanks for Bo Groom for helping us out today. I hope this helps you out too. Again, if you're planning on having negative rates, for crying out loud, make sure it can go negative here. Alright? Alright. Thank you very much. Have a nice day.